Okay, so this little demonstration is going to be all about scale and how we use it to answer problems. First thing we're going to work out is what is a scale. It looks sort of like a ratio, and a ratio being a relationship between two numbers. In this case, we could say that if this were a ratio, the left-hand side would be 100 times smaller than the right-hand side, because we have a ratio 1 to 100. In a scale, there are two components to a scale. These are the paper, which would also be known as a map, or could be seen as a plan. These are the words you might see in the exam. And the right-hand side is real life, or actual size, or something like that. Yeah, that's the reality of what a scale is. And so this is how a scale would be written. Going from paper to real life, how do we work out what one is to the other? So we've got two steps here. Step one is to multiply the paper amount by the scale. And with this example, we'll talk about what we're talking about. Step two, convert the unit to a sensible figure. So in the example below, we have 6 centimeters on paper with the scale 1 to 200. So what I would do is I'd take my 6, I would multiply it by my scale, which in this case is 200. That's going to give me 1,200. And the units will be whatever you put in. They told me it was 6 centimeters, so my answer will be 1,200 centimeters. However, if I ask you to tell me what 1,200 centimeters looks like, you might not be able to tell me. And so we have to convert it to a scale that is sensible, or a unit that is sensible. In this case, the sensible unit I would say is probably meters, with a scale of 1 to 200. How do we get from centimeters to meters? This is where your conversions of measures is useful. We're going to do 1,200 divided by 100 to make 12 meters. And that would be our answer. Our answer in this case would be 12 meters. Okay, so here are some examples to practice that method. Repetition is important to practice. I will give you 5 seconds if you want to pause the video, and then when 5 seconds is done, I will go through the answers. So feel free to pause the video, and then I'll be back in a second. Okay, so hopefully you had a practice on these. We start with 12 centimeters on paper with a scale of 1 to 100. So our method should be 12 times 100 equals 1,200. Divided by 100 again gets me back to 12 meters. And the reason why I've divided by 100 is because there's 100 centimeters in a meter. And so our answer is 12 meters. And I'll do this in red to show that these are the answers. That's probably a smart idea. There we go. Okay, here we've got 4 times by 300, because the scale is 300, equals 1,200. Divided by 100 equals 12 meters. So there again, the answer is 12 meters. And this one, I'll let you know now, won't be 12 meters. We've got 24.2, make this red again. There we go. 24.2 times by 50, which is why we're going to bring out our calculator. This is calculator work, so don't try and do it in your head if you don't have to. It's going to be 1,210. And then divided by 100 would be 100 or 12.1 meters. And so our answer in this case would be 12.1. If you're struggling to do the conversion divided by tens, hundreds, and thousands, then make sure you revise place value, because that will help you do the dividing by tens, hundreds, thousands, and multiplying by tens, hundreds, thousands. All we're essentially doing is imagining that there's a decimal point here, and either moving the decimal or moving the number, whatever you feel more comfortable with. We'll move the number, so we're going to shift everything 2 to the right, and so it would become 12 in front of the dot, 0.1. Okay? And so that is our practice. So good job if you got any of these correct. If you didn't get them correct, then go back through the video again and try again. Pick different numbers and see if you can work out the pattern that you see between these as well. Okay. Going from real life to paper is going the opposite way. So first step is we convert the unit to a sensible figure and we divide by the scale. So in the example here, we've got 5 meters in real life with a scale of 1 to 50. So on a plan or on a map, we're probably going to have a unit of centimeters. And so first, I'm going to do 5 times 100 to get 500 centimeters first. Then I'm going to do 500 divided by 50, which should give me 10 centimeters. And so my answer in this case would be 10 centimeters. We've just done the opposite to what we did before. So if we're going from real life to paper, change the units first, probably to centimeters, because that's more likely to be on a plan, and then divide it by my scale. And so I've ended up with 10 centimeters. Same here, we've got some practice for real life to scale, to go back to paper. So if you want to take 5 seconds again, pause the video, have a go, and come back when you've finished. And I'll see you in a second. Okay, so we've got our 14 meters in real life with the scale 1 to 100. So first of all, I'm going to do 14 times 100 to get our centimeters, which is 1400 centimeters. Then 1400 divided by 100 gets me back to 14 centimeters. And because I started with meters, that's why it's 100 to 100 both times. Here, we've got 23.2 multiplied by 100 equals 2320 centimeters. Then 2320 divided by 400 is going to give me a nice number, which I'm going to do here. So 2320 divided by 400 is 5.8. And so we end up with 5.8 centimeters on our plan. Okay. Finally, we've got 1.21 meters. So that's going to be 1.21 multiplied by 100 is 121 centimeters. 121 divided by 25 equals 5 or 4 and a bit. It's like 4.9 or something. 121 divided by 25. 4.84. Not too far away. 4.84 centimeters. The reason why I write centimeters in the middle, by the way, just so I can keep track of what units I'm currently actually working in. I started with meters, I've ended up in centimeters. When I divide again by the scale, I'm going to stay in centimeters because I put centimeters in. And that would be my answer. So once again, good job if you got any of those. If not, go back through the video and look again, and hopefully it'll start to click as you do more of them. Okay, sometimes we can use big scales too. The same rules apply whether we're using a big scale or a small scale. A big scale may be on an ordnance survey map to demonstrate the distance between two cities, or the width of a city, or a large river, where small scales won't make much sense. So the same rules apply. The only caveat is, be careful about the unit. So in the case of 4, I'll do this in black now, we do 4 centimeters on paper with scale 1 to 25,000. What we're going to have is 4 times 25,000 is 100,000 centimeters. But if I tell you to tell me what 100,000 centimeters actually looks like, you won't be able to tell me. So we're going to say 100,000 divided by 100 equals 1,000 meters. But even still, if I ask you to say what 1,000 meters might be, then you might not be able to tell me. So we're going to convert it to kilometers, in fact. We're going to say divided by 1,000 equals 1 kilometer. And so my answer for this question would be 1 kilometer. The key to these sorts of problems is to think about, in reality, what they're measuring. If we're measuring the distance of, like, the length of a bench, for example, we're probably going to be in either centimeters or meters. We're definitely not going to be in kilometers. If we're measuring the distance between here and Birmingham, or Coventry and Birmingham, which is where I'm from, then we're going to use kilometers because that's a distance between two cities. And that's obviously going to be quite a large distance. And if we were measuring the distance of, say, just an example of like a fingernail or something, we would probably measure in millimeters because that's very small. And so units being reasonable is quite a useful skill to have, and being able to recognize what do I think the unit should be given a certain situation. Okay, so that's using bigger scales. Here's some practice for using bigger scales. I will leave it here. Be careful that sometimes we're going forwards and sometimes we're going backwards. So pause the video and I'll be back in a few seconds. Okay, so here we are with our scale of 10,000. So what we're going to do, we're starting on paper. So it's 10 times by 10,000 equals 100,000. Then we're going to do 100,000 divided by 100 divided by 1,000 equals 1. So our answer should be 1 kilometer. Move that over so you can actually see it a bit better. I'll make it a bit smaller and then it'll fit all in one line. There we go. So that's going to be 1 kilometer. What I've done is divided by 100 to get meters. then divided that by 1,000 to get kilometers. And so if I do it on my calculator just to show you, 100,000 divided by 100 divided by 1,000 gets me to 1 kilometer. Okay? Here we've got 15 kilometers in real life with the scale 1 to 25,000. So first I'm going to multiply by 1,000, multiply by 100 to get to centimeters. So 15 times 1,000 is 15,000, times 100 is 1.5 million. Then we're going to divide it by our scale, which is 25,000, and that's going to be 60. And so this would be 60 centimeters on the map. This could be, that's about 2 rulers, so double this, and that would be the distance between 2 cities on an Ordnance Survey map. Seems about reasonable if they're on opposite corners of the map. Finally, we have 12.52 centimeters on paper with a scale 1 to 50,000. So we're going to do 12.52 times by 50,000 equals our answer. And I would always write the method bits down just in case you make a mistake. You might pick up some follow-through marks. Is 626,000. Then divided by 100, divided by 1,000 equals 6.26 kilometers in real life. There we go. You see here when I start with centimeters and I do a bunch of dividing, I end in kilometers. When I start in centimeters and I only divide by the scale, I keep it in centimeters. And so that's the difference. Once again, good job if you got all of these correct. If not, then go back and try again. It's the same principles. The hard part is remembering which way round we're going. Are we going forwards or are we going backwards? And what method are we doing given those scenarios? Okay. Finally, you might ask or might be asked to make your own scale. So this is an example that I've adapted from a exam style question. The numbers are different, but it's the same sort of principle. We've got a pitch of land, and there are 3 tents, say it's like a festival, and there are 3 tents that want to put themselves on this field. And there are 2 rules that must be followed. Each tent must be 0.5 meters away from any edge, and each tent must be 1.5 meters away from each other. So the very first thing we've got to do, I've got my graph paper, and these are all the bits of information that's mainly for my sake. It might be a bit hard to read, but it's just for my sake, is to make a scale. We've got our graph paper. This is centimeter squared graph paper. We're always going to want to make the graph or the scale as big as is possible because it's easier to read and it's harder to make mistakes if it's much bigger. So I'm going to say my scale, and I'm going to write this down in the bottom left-hand corner. I'm going to say in black, 1 square equals 0.5 meters. That's what I'm going to say. 1 square is 0.5 meters because that's going to give me a nice big scale to use. So this is 15 meters. So how many squares is it going to be? Well, if 1 square is 0.5, then 2 squares is 1 meter. And so I'm going to double my amount of squares. So I'm going to count down to 30. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30. So let's just count that again to make sure. 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Yeah, so that's 30. So that's my left-hand line here. If it's 10, it's going to be 20. So 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. And if it's 5, it's going to be 10. So it's going to go 2, 4, 6, 8, and 10. And so that's my scale. Okay? I'm going to have my plot of land like this. There's a dotted line here, so I'm probably going to replicate that here. You don't have to do it specifically, but I'm going to do that just for ease of seeing it. And we've got our 2 rules to follow. Each tent must be 0.5 meters away from any edge. So I'm going to mark off the parts, and I'm going to do this in a different color. Obviously, you have to draw in pencil, but just to demonstrate, I'm going to show you. If 0.5 meters is 1 square, then I have to be at least 1 square away from any edge. And so we're going to end up with something that looks a little bit like this. The diagonal line might not be exactly perfect, but we've got about a square's width all the way along. That's only half a square. But for the purposes of this exercise, it's not going to make any difference. We've got about a square width between here and here. And we can keep going. So that bit in the red, we can't draw anything in, okay? Now I'm going to draw my first tent. However, they're all in millimeters. So I have to convert them to meters. I'm going to leave some space here because I've got plenty of space to do it. 2,500 millimeters is equal to how many meters? Well, to get from millimeters to centimeters, I divide it by 10, so that'd be 250. Divide that by 100, and I'll end up with 2.5 meters. So I'm going to write that here, move it across a bit so you can see it all in one line. If it would go. There we go. So we've got 2.5 meters. So plot 1 is 2.5 by 2.5. So I can put that in. If 1 square is 0.5, then 2.5 is going to be here, because I can count it up. 0.5, 1, 1.5, 2, 2.5. And then that means it's 5 across. And that also means it's going to be 5 up. So I'm going to count up 5. 1, 2, 3, 4, 5. And 5 across like this. And that's going to be plot number 1. And I would label this as plot number 1. What we don't do is label our sides because they're going to measure them, so we don't need to label them. We just label what plot we're talking about. Now, they have to be 1.5 meters away from each other. So now I know that there are some other squares that can't be used. 1.5 away from each other means 1, 2, 3 here, and 3 in the diagonal as well, and 3 here. So anything inside this red space is now also not used. So I can mark that off too and just do this. So nothing inside the red, that can't be used. Okay? Now, can I fit 4,500 in here? Well, let's see. 4,500 millimeters equals 4.5 meters. If you see the pattern, 25 is 2.5, so 45 will be 4.5. That's going to be how many squares? It's going to be 9 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will fit in here. The other way up is 1,500. So 1,500 millimeters will be 1.5 meters. So it's going to be 3 squares. And so what we end up with is our black line that goes 9 across. 1, 2. Actually, I'll do it like this. I'm going to count up 3. 1, 2, 3. I'll start here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And down 3. And that's going to be plot number 2. Okay. Now, we know obviously that if it's got to be 3 squares away, we can't use any of these. That's no good. And we've got to be 3 squares away at the top as well. So we can't use any of these either. This might be a black line. Yeah, I want to do a red line like this. Okay. So this is also blocked off. We can't put anything here either. But we've got this whole space that we can try and make this fit into. And in fact, in this example, I've got plenty of spaces. Sometimes it might be a bit more cramped and you might have to rotate the shape. But in this example, we've got plenty of space. So 3,000 millimeters equals 3 meters. And 2,000 millimeters equals 2 meters. So we've got to do how many squares by how many squares? It's got to be 6 squares by 4 squares. So 4 here and 6 here would work. And so we could do 1, 2, 3, 4. And 6 across. Like this. And this would be our plot number 3. Now obviously this example I've been very generous and given you loads of space to work with. You could actually probably fit 2 or 3 more tents in here. But this is the general idea. You would mark off where you can't go so that you know where you can go. That's the easiest thing to do. You should always mark off where you don't think you can go, and then you can work out where you can. And that would be my answer. And this could be up here or anywhere really, as long as it makes sense. What the examiner will do is they will mark to see, does your scale make sense? They'll measure your lines and say, yes, it does make sense. They'll say, does it make sense for your plots to be where they are? Yes, they're all 0.5 away from any edge, because this is the edge. So as long as they're further in than that, that's fine. And are they 1.5 away from each other? Yes. This is 3 away from each other. This is 3 away from each other. This is 3 away from each other. So we're happy. In that case, we could say, tick, there's your 5 marks or whatever the question's worth. All in all, this might be a 6-mark question, 3 for doing the scale correctly and 3 for putting them in the right spot, matching all the rules. And that was how you would draw your answer. Make sure your scale is nice and big because it makes it easier to see and try and use the measurements you've been given here to work out what your scale should be. If this was 2.3 or 2.4 instead, I might have chose to do a different number here. I might have done 0.2 squares. 0.2 is 1 square, or 0.4 is 1 square. So I can end up with nice numbers. You want to end up with numbers that will work quite nicely, because you get a little bit of lenience. It's about half a square either side of lenience, but that's not that much. So you want to make it as nice and big as possible to make it easier to do. And that's really level 2 functional skills, all there is to do with scale. There are example questions you can find. Hopefully your practice papers will have examples of questions, but this is scale in a nutshell, and hope that's useful. See you next time.